So we're starting 11.2, guys. Systems of linear equations, and we are studying matrices. So the definition of a matrix is defined as a rectangular array of numbers. Each entry we call it A subscript I subscript J, where I is the row, I is the row, and J is the column. So an example would be, we're going to have, let's do row 1, row 2, skip a few, row I, and the last row, since we don't know where we're ending, let's call it N. So the I represents the row, and the J is going to be the column. So column 1, column 2, skip a few, let's say column J, and then column N, just like that, okay? All right, so if it's the first entry, that's row 1, column 1. So we write A11. So row 1, column 1. Now A, row 2, because that's subscript, I'm sorry, row 1, column 2, so A12. Skip a few, A, row 1, J, and A, row 1, N. So the number, the subscript 1, and you have another number, so that's going to be the column. Now row 2, column 1, that's A21, A22, so represents row 2, column 2, A2J, A2N, okay? And we're going to skip a few down here. So now this is AI1, AI2, AIJ, and AIN. Then our very last row, we call it row N, so that means this is AN1, AN2, ANJ, and this is ANN. So again, the subscript represents row and column. Augmented matrix. So an augmented matrix is a matrix used to represent a system of linear equations. Variables must be on the left side. And constants are on the right. Okay, so let's go and try to do example number 1. Example 1 says, write the augmented matrix of the given system of equations. So as you can see, you have 3 variables, 3 equations. It says here, variables on the left, constants on the right. So we have 6x, so we don't write the x with it, we just write 6. We have 2y, we write the 2, and negative 1z, so that's just negative 1. Now the constant, the first constant of the first equation is 0. Now the second equation, we have 1x, 1y, no z, so that fills in with 0. Yes, you have to have a 0 there. And the constant would be a 4. And the third one, we have 2x, 0y, and 5z, and that constant for the third equation is 2. So that's an augmented matrix. Coefficient matrix is an augmented matrix with only the left side. Okay, so we are going to use example 1 to do a coefficient matrix here. So the only difference is that now you only have the left side, which is all the variables, okay? 6, 2, -1, 1, 1, 0, 2, 0, 5. And that's the difference between an augmented and a coefficient. Reduced row echelon form. There are 3 conditions, okay, students? Okay, condition number 1. Entry in row 1, column 1 is a 1, and all the zeros below it. So entry in row 1, column 1, that means is A11, is a 1, and zeros below it. Condition number 2. The first non-zero entry in each row after the first row is a 1 and only zeros below it. The first non-zero entry in each row after the first row is a 1 and only zeros below it. Last condition. Any row that contains all zeros. Any row that contain all zeros to the left of the vertical bar must appear at the bottom. Must appear at the bottom. All right, so let's draw up an example of your reduced row echelon form. So I'm going to make a matrix like that. Now it says here, condition number 1, entry in row 1, column 1, it's a 1. Okay, so that means row 1, column 1, it's 1, and it says zeros below it, just like that. Then, so that means is, if I were to do 3 columns, right, so these 2 spots right here, those 2 spots can be anything it wants to be. So you don't have to have a 0, you don't have to have a 1, you can have any number you want. You can have a 0, you can have a 1, it's just that you can have anything else you want, okay? So let's call it A and B. Now, condition number 2 says the first non-zero entry in each row after the first row, it's a 1. So again, here's a 1. And then that means that spot could be anything you want to be. It can be 0, it can be 1, it can be non-zero, non-1. Then that means we have 0 here, and this is now a 1. So look at the diagonal. The diagonal, it's all 1s, okay? Now we have the constant on the right side. It can be anything it wants to be, so let's just use the variable G, E, and F, where A, B, C, D, E, and F, they're all in a set of real numbers. I mean, it can be anything they want to be, okay? All right, inconsistent is when the system of the equations don't meet. That means you have no answers, okay? Is when the system of equations don't meet, aka no solution. Oops. Consistent is when the system of equations have at least one solution. Okay, so normally, guys, you have one solution or no solution or infinitely many solutions. Okay, so the two choices would be one solution for consistent, and the second one would be infinitely many. Now you're going to have infinitely many solutions when you have all of your equations or all of your lines line up one on top of another. You have one solution is when they intersect at exactly one place.